Welcome to the deep dive. If you've ever, felt that crushing frustration of trying to lose weight only to see it creep right back on, then this deep dive is absolutely for you.
Yeah, it's such a common story, isn't it?
Totally. We've all heard that advice, eat less, move more. But for so many people, that feels, well, not just difficult, but honestly, pretty much impossible sometimes.
People put in so much effort, right? They push themselves, and yet the weight almost inevitably seems to return.
So where do we turn?
Well, our source for this deep dive is Dr. Andrew Jenkinson's really compelling book, Why We Eat Too Much. Now, Dr. Jenkinson, he's a bariatric surgeon.
Okay.
And after years, literally years, listening to thousands of his patients, he had this big realization. Our usual understanding of obesity, it's fundamentally flawed.
Flawed how? If that eat less, move more idea is off, then what is really going on? Why is something that seems so simple, losing weight, actually so incredibly hard?
And why can't people sustain it? Why do they end up considering extreme things like, stomach removal surgery?
Yeah, exactly. This book promises not just an explanation, but maybe a real path forward.
Yeah.
And hopefully in a way we can all understand without tons of jargon.
Yeah, that's the goal. And here's the central idea, the big reveal that changes everything. Your weight. It's not really under your conscious control.
Conscious control. What do you mean?
Your body has this thing called a weight set point. Think of it like a pre-programmed thermostat for your weight.
Okay.
And it's controlled by your subconscious brain. And this system, it powerfully resists your efforts to change that set point.
So this isn't about willpower then. That's huge.
Not really, no. It's about biology. Deep-seated biology running the show.
Wow. Okay, so if biology is in charge, what does that mean for how we usually try to lose weight? Let's start with that basic idea. Energy in versus energy out.
Right. The simple equation.
Yeah. The belief is energy you eat minus energy you burn equals energy stored as fat. Seems logical. Eat more than you burn, you store fat. Simple.
It sounds perfectly logical on the surface. But here's where it gets, well, really interesting. If that equation was the whole story, we'd expect some pretty wild numbers.
Yeah, so?
Well, take the average American man. In the year 2000, he was eating about 500 calories more per day than he did back in 1980.
Okay, 500 more calories a day. So if you apply that simple energy in, energy out rule.
You'd predict a weight gain of, wait for it, 312 kilograms over just 12 years.
312 kilos, that's what, nearly 700 pounds? It can't be right.
Exactly. It's unbelievable. But the actual average weight gain for those men during that time, only 6 kilograms.
6. So about 13 pounds.
Just 13 pounds. That massive gap, that huge discrepancy, it screams that something much more complex is happening.
Right. It tells us that equation is missing something big.
It points to the fact that most of the energy we use isn't even under conscious control. About 70% of our daily energy burn, that's for subconscious stuff, breathing, heartbeat, keeping your temperature steady.
That's the basal metabolic rate, the BMR.
That's your BMR, exactly. An actual active exercise. For most sedentary people, it's a tiny fraction, maybe only 2 or 3% of the daily total.
So our conscious effort, like going to the gym, barely scratches the surface of our total energy use.
Pretty much. It shows our bodies have this master control system working behind the scenes.
It reminds me of how our bodies handle water. We drink, over 550 liters a year, like 5 bathtubs full?
Yeah.
And we never consciously measure it, do we? It just happens.
It's this incredibly accurate negative feedback system. Completely subconscious. It's got a sensor, a couple of switches. It just works.
So Dr. Jenkinson thinks our fat storage works like that too.
Very similarly, yes. The idea is the body has a sensor that detects how much fat is stored. When it senses a change, it sends out a hormone signal.
Oh, hormone.
Called leptin. And that leptin signals 2 key switches. Switch number 1, appetite, how much energy you feel like taking in.
Okay, hunger levels.
And switch number 2, your BMR. How much energy your body decides to burn off without you even thinking about it.
So it's adjusting both sides of the equation subconsciously, like a safety mechanism.
Kind of, yeah. The system actually nudges us to eat a bit more than we strictly need.
Really? Why?
And then it just burns off the excess. It's like how we drink more water than the bare minimum for survival. It provides a buffer. So when we do try to cut calories,
the body just adjusts.
It copes easily. It often just slows down the BMR, that metabolic rate, to match the lower intake. It's trying to maintain that set point.
Okay, so we've got the biology BMR, hormones like leptin working subconsciously. But if the body is so good at regulating, what makes the set point go up in the first place? What influences it?
That is the million-dollar question, isn't it? And it seems it's not just how much you eat, but the quality of the food.
Quality over quantity.
Dr. Jenkinson uses this great analogy. Think about cows in India. They eat natural stuff. They stay pretty lean.
Right.
Now compare them to, say, English cows bred for beef. They're fed this specific mix of grain and oil to fatten them up quickly.
Okay, so it's the feed that makes the difference.
And studies on rodents show the same thing. You want to make rats fatter. You don't just give them more of their normal food. You give them high-calorie, high-fat, processed canteen food.
Canteen food, like junk food.
Basically, yeah. And that type of food actually seems to raise their weight set point.
And finding food that isn't like that canteen food in our modern world.
Yeah.
Well, that's the challenge, isn't it?
It's incredibly hard. Outside the fresh produce section, it often feels like a processed food landscape. It's a huge factor.
Okay, so food quality is one thing. What else?
Another massive one is genetics. There's this fascinating study by Jane Wardle on identical twins, including some separated at birth.
Twin studies, right? They're always interesting.
And what she found was striking. About 75%, 3/4 of how consistent a person's BMI was seemed to be down to their genes.
75%. Wow.
Yeah. And only about 10% was linked to their home environment growing up.
So that really shifts the blame, doesn't it? Away from, bad choices or how you were raised.
And puts it more onto the biological hand you were dealt, interacting with the environment you're in.
Which leads us nicely into evolutionary ideas like the thrifty gene hypothesis. What's that about?
Well, the idea from James Neal is that over millennia, genes that made people really efficient at storing energy, storing fat, helped them survive famines.
Made them more likely to live and have kids during tough times.
Exactly. So those thrifty genes got passed down. And you can see the potential impacts today in populations whose ancestors faced really harsh conditions or migrations.
Like who?
Like Pacific Islanders or Paima Americans who sadly have about a 50% diabetes rate now. Or African Americans where obesity rates are high, especially among Black women.
Because their genes, selected for survival and scarcity, are now a disadvantage when food is everywhere, especially processed food.
Precisely. Their metabolism is sort of too efficient for our modern Western diet.
And then there's epigenetics. That's a newer field, right? How does
Yeah.
that play in?
It's fascinating. Epigenetics is about how your environment can actually switch genes on or off, changing how they're expressed. It's like environmental cues tweaking your genetic blueprint.
So it's not changing the genes themselves, but how they work.
Exactly. Think about the Emirati population in Dubai. Their ancestors' genes were suited for desert survival, scarcity.
Right.
But now they're living surrounded by modern food courts. That rapid environmental shift means their genes are kind of metabolically unsuited, leading to very high obesity rates.
Wow. And it gets even more complex with maternal influence, doesn't it?
It really does. If a mother is undernourished during pregnancy, the baby's genes can get turbocharged for survival.
Preparing for a tough world.
Yeah. But then, if that child grows up in a place with plenty of food, they're essentially predisposed to obesity.
Okay, that makes a kind of harsh sense.
Yeah.
But what about the other way around? If the mother is overweight or obese during pregnancy?
Paradoxically, that also seems to pass on obesogenic traits like a bigger appetite, more aggressive food-seeking behavior in the child.
Why would that happen?
The current thinking is maybe it's due to micronutrient deficiencies in the mother's diet, especially if she's eating a lot of processed food.
Ah, so even with enough calories, she might be lacking essential vitamins or minerals.
Right. And the fetus's genes might adapt by basically programming a higher drive to eat to ensure it gets enough nutrition later on.
That creates a worrying cycle through generations.
It does. Each generation might be getting primed with stronger obesity traits because of these epigenetic changes passed down from mothers, even grandmothers. It really makes you wonder, what does this mean for the future?
It's a really sobering thought. And it brings us to why diets often fail so spectacularly. You mentioned shows like The Biggest Loser.
Right. People see the dramatic weight loss on screen.
But what happens afterwards?
That's the hidden truth. Scientists tracked the contestants long after the show ended, and 6 years later, their metabolisms had crashed.
Crashed. How badly?
They were burning hundreds, sometimes 600, 700 fewer calories per day than you'd expect for their size, even compared to before the show.
Wow. That's the body fighting back metabolic adaptation.
Exactly. Less energy comes in through dieting, so the body drastically cuts how much energy it puts out. It's defending that set point fiercely. It makes keeping the weight off incredibly difficult, almost an unfair fight.
That's just startling. So the body actively works against long-term weight loss after a diet.
Mm-hmm.
It sounds like the yo-yo dieting experience many people report.
It absolutely confirms it. Animal studies back this up too. You put mice on diet cycles, lose weight, regain it, lose it again.
What happens?
They experience overshoot. After each period of regaining weight, they actually end up heavier than before the diet started. It's a pattern so many human dieters recognize.
So frustrating. And our nervous system gets involved too, the autonomic nervous system.
Yes, the ANS. It's your body's automatic control panel, handling things you don't think about. It has different modes.
Modes, like what?
Well, when we overeat, especially processed foods, it can trigger the fight or flight response, the sympathetic nervous system. You get adrenaline.
Do you feel energized?
Yeah, high pulse, higher blood pressure, glucose levels up, maybe even some endorphins. Dr. Jenkinson calls it feeling like it's holiday time. Your body's trying to burn off the excess energy.
But that sounds stressful long term.
It is. The cost of being constantly in that state can be high blood pressure, eventually type 2 diabetes.
And what about when you're dieting? What mode is that?
That tends to activate the other side, the rest and digest system, the parasympathetic nervous system. Its job is to conserve energy.
Ah, so that explains the fatigue, the brain fog, feeling down.
Precisely. That's your body perceiving a famine and trying to slow everything down to save fuel. It's a common experience for dieters.
And you mentioned thermogenesis, burning energy as heat.
Yeah, the body has this ability. Scientists discovered it decades ago, even finding substances that could dramatically ramp up metabolism, increase heat production. Finding a safe, natural way to tap into that is still a challenge, though.
Okay, so the picture is getting clearer. Simple calorie counting misses all this complexity. Let's talk about the real drivers of appetite. Leptin came up earlier. That discovery in '94 was big, right?
Huge. Leptin is made by fat cells. It's supposed to tell your brain, hey, we've got enough energy stored here. You can dial down the hunger and maybe burn a bit more.
So it regulates appetite and metabolism based on fat stores.
In theory, yes. And we saw proof with those rare cases of leptin deficiency mice and some humans, like the cousins Dr. Sadaf Faruqi studied. They had no leptin, were uncontrollably hungry, and massively obese.
But leptin injections helped them.
Cured them, basically. It showed how powerful leptin is meant to be.
Okay, so if lack of leptin causes extreme obesity, then for most people who are overweight or obese, surely giving them more leptin would be the answer.
That's what researchers thought initially, but here's the crucial, frustrating twist. For the vast majority of obese people, their leptin levels are actually high, sometimes very high.
High, but they're still hungry and gaining weight.
The problem isn't a lack of leptin. It's that the brain can't properly hear the leptin signal. It's called leptin resistance.
Leptin resistance. So
Right.
the message is being sent, but it's not getting through.
Exactly. Imagine your brain trying to read that vital, we have enough energy signal through thick fog. It can't see it clearly. So even though the body has plenty of fat stored, the brain thinks it's starving.
And that drives the intense, persistent hunger.
That drives the insatiable hunger. It's a tragic disconnect.
It sounds like a vicious cycle. What causes this resistance?
Well, high levels of another hormone, insulin, seem to play a big role. Insulin often spikes after eating sugar and refined carbs. High insulin appears to sort of dilute or interfere with leptin signal at the brain level.
Okay, so sugar and refined carbs lead to high insulin, which messes with leptin.
And it gets worse. Inflammation, which is often a result of the typical Western diet, high in processed foods and certain fats, can also physically block leptin sensing in the brain.
So insulin resistance and leptin resistance kind of feed each other.
They absolutely do. The brain thinks there's no energy, keeps signaling hunger, you eat more, insulin stays high, leptin resistance gets worse. It's a downward spiral. That man Dr. Jenkinson saw at the Dubai breakfast buffet, eating enough for 10. That's leptin resistance in action.
And we've all felt that sugar roller coaster, right? Eat something sugary.
You get that quick energy spike, blood sugar shoots up,
Then the big insulin surge to deal with it,
and then the crash, blood sugar plummets.
leaving you feeling shaky, maybe irritable, and craving more sugar.
Exactly. It creates this cycle that keeps insulin levels elevated throughout the day, constantly pushing that weight set point higher.
And the food industry definitely jumped on that, didn't they? Promoting snacks between meals.
They absolutely capitalized on those sugar crashes. More eating opportunities, more processed food sales, and crucially, more insulin exposure for us, further driving up the average set point.
It really makes you step back and ask, how did we even get here as a species? Our relationship with food seems so messed up now.
Dr. Jenkinson argues that understanding our evolution is key. He makes this amazing point that cooking actually made us human.
Cooking. How?
Think way back. Evolution from simple cells to complex creatures with mitochondria are cellular power plants. We have a limited energy budget as humans,
Okay.
and our brains. They are incredibly energy hungry. They use a huge chunk of our daily calories.
So where did that energy come from?
That's the expensive tissue hypothesis. To evolve our massive brains 4 times bigger than our ancestors, we likely had to trade off energy from another expensive organ.
Which organ?
Our gut. Our large brains evolved alongside smaller guts compared to our primate relatives.
Smaller guts. But don't we need guts to get energy?
Yes, but what changed everything was taming fire, maybe 1 million years ago. That allowed cooking.
And cooking.
Cooking pre-digests food. It breaks down cell walls, proteins. It makes nutrients much easier to absorb. It saves a ton of energy that would otherwise be spent on digestion.
Ah, so cooking freed up metabolic energy.
Exactly. That metabolic room allowed the gut to shrink and the brain to expand. Cooking is fundamental to who we are. It explains our fascination with food.
So what did our hunter-gatherer ancestors actually eat using this amazing new tool of cooking?
Their diet was like a natural supermarket. Unprocessed stuff. Men hunted, but they prized the fatty parts organ meats like liver, brain, bone marrow, not just lean muscle meat.
Fat was good.
Fat was highly valued energy. Women gathered roots, tubers, fruits, nuts, seeds, but crucially, it was all whole, unprocessed food.
And they stayed fit.
Remarkably fit, even when food was plentiful. Think about chimps in the wild. They eat a lot, but they don't get obese on their natural diet.
But then things changed. Agriculture arrived.
And it wasn't all positive, nutritionally speaking. Early farming communities often had less dietary variety. They were shorter, sometimes sicker.
And then sugar enters the story.
Yeah, sugar was once incredibly rare, a luxury. Then, tragically, the slave trade made sugarcane production cheap, flooding the market.
So it became common.
Even the Victorian poor, who often ate relatively healthy, by chance, fresh foods, awful, not much sugar, saw their diets change as cheap beet sugar became available later on.
And the Industrial Revolution turbocharged all this?
Absolutely. Food became big business. The priorities shifted to shelf life, transportability, profit. That meant processing.
Removing things that spoil, like good fats.
Yep. And adding things that preserve or make processed food palatable: sugar, salt, artificial additives, those E numbers. Even wheat was engineered. Dwarf wheat gave high yields but less nutrition, basically becoming pure starch, hitting the blood like sugar.
It sounds like a perfect storm brewing. And then came the nutritional advice, the heart of the matter, as Jenkinson calls it.
This is crucial. In the 1950s, a researcher named Ansel Keys published influential studies linking saturated fat to heart disease.
The diet heart hypothesis.
Yes, but his research methods were, let's say, questionable. He seemed to cherry-pick data that supported his theory. And then, even more concerningly, in 1967, the sugar industry secretly paid Harvard scientists to publish a review in a major medical journal.
Paid them. To do what?
To downplay the evidence linking sugar to heart disease and shift the blame squarely onto saturated fat and cholesterol.
That's shocking.
It had a massive impact, and the understanding of cholesterol itself was oversimplified. We now know saturated fat mainly raises good HDL cholesterol and a generally harmless type of LDL.
So what raises the bad LDL?
The really small, dense, harmful LDL particles,
Yeah.
those are increased more by carbohydrates and sugar, not fat.
But this flawed science influenced official advice.
Hugely. The 1977 McGovern report in the U.S. enshrined the low saturated fat advice into official dietary guidelines.
And the food industry responded.
They reformulated everything, took out the fat,
And replaced it with.
sugar, and cheap vegetable oils to make things taste okay. The result: average sugar consumption soared from maybe 80 pounds per person per year to over 100 pounds. And vegetable oil intake exploded, jumped 300%, from around 15 pounds to 60 pounds per person per year.
This is unbelievable. And you mentioned the drug industry.
Well, the focus on cholesterol, driven by that flawed hypothesis, perfectly paved the way for statin drugs. It's now a multi-trillion-dollar industry, heavily invested in keeping that focus on cholesterol, even as the evidence against the original diet heart link crumbles.
Jenkinson proposes this radical idea. Could obesity be a deficiency disease, like scurvy or beriberi?
It's a really thought-provoking parallel. Those diseases baffled people for centuries, cost millions of lives, all because a vital nutrient was missing and nobody realized it.
Vitamin C for scurvy, B1 for beriberi.
Right, and the modern obesity epidemic took off right around the time those low-fat dietary guidelines, the McGovern report, came in. So Jenkinson asks, Did we accidentally remove something essential from our diet?
And he thinks it might be related to fats. But didn't we just say fat was demonized?
Yes, but specifically types of fat. This brings us to omega-3 and omega-6 fatty acids. Both are essential, our bodies need them but can't make them.
Okay, omega-3 and omega-6. Where do we get them?
Omega-3 you can think of as sunshine fat. It comes from things that grow in sunlight green leaves, the plankton fish eat, so fatty fish, and animals that eat grass.
And omega-6.
That's more the autumn fat. It's concentrated in seeds and grains.
So what's the problem? We eat seeds and grains.
The problem is the ratio. Our ancestors and primates like chimps had a much more balanced ratio of omega-6 to omega-3 in their tissues, maybe around 4.1 or lower. But our modern Western diet, it's completely skewed.
How skewed?
Drastically, largely because we eat so many processed foods made with cheap vegetable oils derived from seeds, corn oil, soybean oil, sunflower oil, and we eat fewer green, leafy veg, and grass-fed animal products. Our tissue ratio has shot up maybe to 15.1, 20.1, even higher.
From like 8% omega-6 in tissues in the 60s to over 20% now.
Something like that, yes. It's a massive shift in our cellular makeup, and the consequences are huge.
What kind of consequences?
This imbalance is being linked to all sorts of modern health issues, not just obesity, but inflammation, heart disease, even brain health problems like Alzheimer's, dementia, anxiety, mood disorders. One expert, Jenkinson, quotes, calls it a change to the human brain as serious as climate change.
That's terrifying. How does this omega ratio tie back to the weight set point?
Evolutionarily, a high ratio of omega-6 from seeds ripening in autumn to omega-3 might have acted as a signal to the body. Winter is coming. Time to store fat.
An autumn signal.
Yeah, triggering ancient survival responses. Increase appetite, gain weight, become a bit insulin resistant to conserve energy for the lean winter months.
But because our diet is permanently high in omega-6 now,
That autumn signal is switched on all the time. Our bodies are constantly being told to prepare for a winter that never arrives, keeping the set point elevated.
wow. So it's like our own food is tricking our ancient biology. Are there other things that trigger the set point? What about stress?
Definitely. Chronic stress pumps out the hormone cortisol, and high cortisol can ramp up appetite, especially for comfort foods, and nudge the set point higher. Think of the freshman 15. It's not just the cafeteria food. It's often the stress of leaving home.
That makes sense. What about relationships, like marriage? People joke about letting themselves go.
There's actually a biological basis. Weight gain after settling down is common. Hormonal shifts can play a role, maybe slightly lower testosterone in men, higher estrogen in women, potentially nudging the set point up, biologically preparing for nesting and family.
So it's not just laziness. It's hormones.
Yeah.
And sleep. Does that affect it?
Hugely. Disruptions like shift work, jet lag, even just too much artificial light at night reducing melatonin production.
Melatonin, the sleep hormone.
Yes. Lower melatonin seems to decrease leptin sensitivity, making the brain deaf to the fullness signal, and can increase cortisol. Both push the set point up.
And finally, migration. Moving countries.
Yeah, that's a big one. Someone moving from, say, rural Italy, where maybe 13% of the food is processed, to the USA, where it's closer to 70%.
They often gain weight.
And the amount often corresponds to the omega-6 ratio difference in the food supply. It's a powerful environmental effect on that biological set point.
Okay, so after digging into all this, the biology, the hormones, genetics, epigenetics, the food environment, stress, sleep, it's crystal clear why just saying eat less, move more is so inadequate. It's like telling someone to fight their own body's thermostat.
Exactly. So Dr. Jenkinson's approach isn't about fighting your body. It's about understanding its signals and then changing your environment, your food, your habits to gently persuade your body to lower its set point.
Leading to more effortless and, crucially, sustainable weight loss.
That's the goal. And it starts with preparation. This is very much a do-it-yourself project.
What kind of preparation?
First, realistic expectations. You might not get back to your high school weight, especially if you have strong genetic predispositions to obesity. The aim is healthier, happier, and sustainably slimmer.
Okay, managing expectations. What else?
Preparing your home environment. Get your kitchen ready for cooking real food from scratch. Jenkinson stresses home cooking is essential because eating out or getting takeaway is often navigating a food desert of processed options.
And he says, throw away the scales.
Yeah. He argues they just fuel obsession and don't reflect the deeper changes happening. Focus on how you feel, how your clothes fit. Also, optimize your bedroom for sleep blackout curtains, cool temperature, no screens before bed to help melatonin.
Makes sense. What about time? This sounds like it takes time.
It does. You need to consciously find maybe 1 or 2 extra hours a day. Where from?
Uh-huh.
By cutting back on less productive things, maybe less Netflix, less aimless social media scrolling, use that time for food prep, activity, rest.
And mental prep.
Crucial. Acknowledge that sugar and refined carbs can be genuinely addictive. They trigger dopamine, like drugs. Be ready for potential withdrawal cravings, maybe feeling rough for a bit as your body adjusts. Cold turkey is often necessary.
And for people with things like binge eating?
He strongly emphasizes the value of professional help, like from a clinical psychologist, to address the underlying psychological patterns alongside the dietary changes.
Okay. The book also talks about mindful eating, right? Getting back in touch with hunger and fullness cues.
Yes, because our modern culture encourages mindless eating, shoveling food down at our desks in front of the TV. We lose that natural intuition.
So how do we reconnect?
Simple exercises can help, like taking one small piece of chocolate and really paying attention to the smell, the texture, the taste dissolving slowly. It retrains your brain to notice sensations.
And managing cravings, they feel so powerful.
The key is reframing them. See a craving not as a personal failing, but as an autonomic stress response your body's sending out a signal. Don't just react. Use a breathing space technique. Pause. Notice the craving, the thoughts, the feelings. Breathe. Then choose how to respond rather than being automatically driven by it.
Okay, let's get practical. The 5 steps to actually lowering the set point. Step 1 is eat more, rest more. Sounds good. How does that work?
It's about lowering average daily insulin levels and cortisol, so eat more of the right things. Replace sugar, wheat, and corn products with natural whole foods.
What about breakfast? Lots of people grab cereal or toast.
He suggests avoiding that typical high-carb start. Go for something like a full English, but think meat, eggs, cheese, non-starchy veg like mushrooms, tomatoes, protein and fat to keep you full, stabilize blood sugar, and avoid that mid-morning crash and craving cycle.
And lunch and dinner.
Plan ahead. Cook at home using fresh vegetables, dairy, meat, fish, again, minimize the wheat, sugar, corn, and make meals sociable, enjoyable occasions, not rushed fuel stops.
And the rest more part.
Improve sleep quality. That means good sleep hygiene. Dim lights for a couple of hours before bed to boost melatonin. Create a calming routine, maybe reading a book instead of scrolling your phone.
Okay, step 3 is prime your cells, your personal blue zone. What does that mean?
It's about changing your internal environment at a cellular level to be more like people in blue zones areas known for longevity and health.
And their diets are key.
Yes. Often lots of fish, vegetables, healthy fats like olive oil, and crucially very little processed food, especially those man-made vegetable oils. So the goal here is to fix that omega-6 to omega-3 ratio we talked about.
So cut down omega-6.
From seed oils, corn, soy, sunflower, etc., processed foods containing them, maybe even excess nuts and grains for some people.
And increase omega-3.
From fatty fish, salmon, mackerel, sardines, grass-fed meat and dairy if possible, leafy greens, perhaps flax or chia seeds.
This really changes how you shop.
Absolutely. Jenkinson loves Michael Pollan's rules. Don't buy anything your great-grandmother wouldn't recognize as food. Don't buy food that doesn't go off. Avoid packages with more than 5 ingredients or health claims.
So stick to the perimeter of the supermarket. Or better yet, the butcher, the fishmonger, the greengrocer.
That's the idea. Real whole food.
Got it. Step 4, tone your muscles. Isn't exercise just about burning calories?
That's the common view, but Jenkinson argues its main benefit for set point isn't the calories burned during the exercise. It's about the after effects.
Like what?
Lowering stress hormones like cortisol, and, really importantly, improving insulin sensitivity, making your muscles better at taking up glucose without needing so much insulin. Both help lower the set point.
So what kind of exercise? Hours in the gym?
No, he advises against grueling endurance stuff unless you love it. Focus on consistency and enjoyment. Maybe 2-3 times a week, minimum 20 minutes, enough to get a bit sweaty. And importantly, maintain muscle mass. Muscle is metabolically active.
How do you do that? Weights.
Doesn't have to be heavy weights. Bodyweight exercises work great. He even mentions things like this simple 7-minute workout app as being effective for maintaining muscle. Practical and sustainable is key.
Okay. Finally, step 5, reduce your insulin by focusing on glycemic load, or GL. What's GL?
Glycemic load is a bit more sophisticated than just counting carbs or using the glycemic index. It considers both how quickly a food raises blood sugar and how much carbohydrate it contains per serving. It gives a better picture of the actual insulin response.
So it's about managing the total sugar hit from your food across the day.
Exactly. The aim is a moderate low-carb approach, not necessarily strict keto unless advised. Target a daily GL of around 100 initially, maybe aiming for 80 or lower long-term.
What foods have low GL?
Meat, fish, eggs, cheese are basically GL zero. Most vegetables, especially non-starchy ones, are very low. Fruits vary, but many berries are low.
And higher GL foods.
Things like potatoes, white rice, pasta, bread, sugary drinks, sweets, those have a high GL. The idea is to reduce those staples.
But if you cut back on those, won't you be hungry?
You need to consciously replace them. Fill up on low GL vegetables, protein sources, and healthy fats. That combination provides satiety without the big insulin spike.
And what about carbs after exercise? Don't athletes need carbs?
Yes, exercise uses up muscle glycogen. You need to replenish it. Jenkinson suggests if you burn, say, 350 calories exercising, you should aim to consume about 75 grams of healthy carbs afterwards to refuel your muscles properly.
Okay, that makes sense. Phew, what a journey through our biology and food environment. To wrap up, let's revisit that log shed analogy. It really stuck with me.
It's a powerful way to picture it. House number 1. The naturally slim person, living right next to a forest.
Loads of wood available.
Exactly. No need to hoard logs. Any extra just gets burned effortlessly. Their brain knows food, wood, is abundant.
House number 2. Someone overweight.
Their owner remembers a past log delivery strike, maybe icy weather is forecast. They're anxious. They want that shed packed full just in case.
Their set point is high due to perceived scarcity or stress in the past.
Precisely. Their brain is trying to protect them based on past experience.
And house number 3. The person who is obese and leptin resistant.
This is the tragic one. Their shed is actually broken, overflowing with logs spilling out everywhere. But the owner, the brain, is getting faulty signals. It thinks the shed is completely empty.
So it keeps ordering more wood, despite being buried in it.
Constantly ordering more, driving that insatiable hunger because it perceives a desperate lack of reserves, even though the body is carrying massive energy stores.
That analogy just perfectly sums up why obesity, for many, isn't greed or laziness.
It's the brain reacting, sometimes incorrectly, to a complex mix of genetic, historical, and environmental signals. It's fundamentally misunderstanding the body's true state.
So this deep dive, based on Dr. Jenkinson's work, it offers a different path, not a quick fix diet.
Definitely not. But a framework for understanding your own biology and making sustainable changes to your environment to work with your body, not against it. A path to potentially a better long-term health and happiness.
The promise being, if you grasp these principles, you might never need another fad diet book again.
That's the hope. Understanding the why empowers you to find your how.
It really makes you think about how deeply our modern food world influences us, often without us even realizing. Which brings us to our final provocative thought for you, the listener. Given how strongly our biology, shaped by evolution and environment, nudges our weight, how much conscious choice do we truly have? Or is our biology always subtly guiding us back towards its perceived safe, even if that's overweight set point? And maybe more practically, what's one small intentional change you could make today, starting now, to begin gently influencing your own set point in a healthier direction?